Good afternoon, everyone. In this video, I'm going to explain the MLT Experiment 1, Exploratory Data Analysis and Data Preprocessing. This experiment is divided into two parts. And the first one is Exploratory Data Analysis using Toyota 1A.CSV. And the second one is Data Preprocessing using Toyota 1B.CSV. The goal is to understand the data set, detect patterns, identify outliers, and prepare the data for machine learning models. And the part A is exploratory data analysis. First, the required libraries are imported. Pandas for data manipulation, NumPy for numerical operations, Matplotlib and Seaborn for visualization, SkyP stats for statistical calculation. Then the dataset Toyota 1A.CSV is loaded into a data frame. DF is equal to pd.read.csv of Toyota 1A.CSV. This data frame contains information about Toyota cars, including features such as age, price, fuel type, weight, kilometer, quartile tax, guarantee period, gives, etc. And the first one is display the number of rows and number of columns. df dot shape. This shows the size of the data set, rows, number of observations, columns, number of features. This helps understand the data set dimension. And the second one is identify categorical and numerical columns. Using data types, categorical columns, text values like fuel type, and the numerical columns, numbers like age, price, etc. This helps understand which features need encoding or scaling later. And the third one is find minimum, maximum, and mean of numerical columns. df.agg min max mean. This gives basic statistical summary of numerical data. It helps us understand lowest value, highest value, and average value. And the fourth one is five number summary of age. The five number summary includes minimum first quartile Q1, median third quartile Q3, and then maximum. This describes the distribution of the age feature. A box plot is also plotted to visualize this distribution. And the fifth one is detect outliers using IQR interquartile range. Quartiles in guarantee period are detected using IQR formula. IQR is equal to Q3 minus Q1. Lower bound is equal to Q1 minus 1.5 into IQR, and the upper bound is equal to Q3 plus 1.5 into IQR. Values outside this range are considered outliers. These outliers are displayed with their row index. A box plot is used to visually verify them. And the sixth one is detect outliers using Z-score. Another method used is Z-score. Formula Z is equal to X minus mean by standard deviation. If Z is greater than 3, then the value is considered an outlier. The program prints row index outlier value, then Z-score. And the seventh one is correlation between features. Correlation is calculated for age, price, quarterly tax, weight using df.cor function. Correlation value range between -1 and +1. +1 means strong positive relation, -1 means strong negative relation, 0 means no relation. And the eighth one is find highest positive and negative correlation. The program identifies future pairs with the strongest positive correlation, future pairs with the strongest negative correlation. Diagonal values are ignored because they are always one self-correlation. And the ninth one is future pairs with correlation greater than 70%. If modulo of correlation is greater than 0.7, then features are strongly correlated. These features may affect model performance. And the 10th one is skewness analysis of CC. A histogram distribution is plotted for the future CC. Skewness indicates the asymmetry of data distribution. Positive skew means right skew. Negative skew means left skew. Zero means symmetric. The skewness value is calculated using df of CC dot skew. And the 11th one is univariate analysis of fuel type. A count plot is used. It shows how many cars belong to each fuel type like petrol, diesel, CNG. This helps understand categorical data distribution. And the 12th one is univariate analysis of age. Two plots are used. Swarm plot shows individual data points, and then violin plot shows distribution and density of the future. This helps visualize how age values are spread. And the 13th one is relationship between age and price. A scatter plot is used. This helps analyze whether price increases or decreases with age. Generally, older cars tend to have lower prices. And the 14th one is bivariate analysis. Fuel type with age. A box plot is used. This shows how age varies for each fuel type category. Example insights. Diesel cars may have different age distribution than petrol cars. And the 15th one is relationship between two categorical variables. Variables include fuel type, gears. Two methods are used. Crosstab shows frequency table. Count plot shows graphical distribution. This helps understand how gear counts vary with fuel type. And then 16th one is multivariate analysis. A pair plot is used for age, price, kilometer, weight with fuel type as hue. This shows relationship between multiple variables simultaneously. And then part B is data pre-processing. Now the second data set Toyota 1B.CSV is used. The aim is to clean the data set before machine learning. And the 17th one is identify missing values. The program calculates number of missing values, percentage of missing values. This helps decide how to handle missing data. And the 18th one is mean imputation. If missing value in a numerical column less than 10%, they are replaced with the mean value. Mean imputation helps maintain the overall distribution of data. And the 19th one is nearest value imputation. Missing values are filled using nearest interpolation. This method estimates values based on neighboring data points. And then 20th one is mode imputation. For categorical columns, missing values are replaced with the mode. Mode is equal to most frequent category. And the 21 is drop columns with more than 10% missing values. Columns having too many missing values can reduce model accuracy. So such columns are removed. Data set size before and after dropping is displayed. And the 22nd is remove outliers using Z-score. Rows with Z-score greater than 3 for guarantee period are removed. This helps remove extreme values that may distort models. And the 23rd is calculate duplicate rows. This program checks duplicate rows across all columns. Percentage of duplicates is calculated. And the 24th is remove duplicate rows. Duplicates are removed to ensure data integrity. Data size is shown before and after removal. And the 25th question is check duplicates based on specific columns. Columns used price, age, MFG month, fuel type. This checks partial duplicates. And the 26th question is remove those duplicates. Rows with identical values in the above columns are removed. And the 27th is minimum maximum normalization. Formula x minus minimum divided by maximum minus minimum. This scales values between 0 and 1. Scatter plot is used to visualize normalized values. And the 28th question is it score normalization? X minus mean divided by standard deviation. This transforms data so that mean is equal to 0, standard deviation is equal to 1. And the 29th question is label encoding. Categorical values like fuel type are converted into numbers. Example, petrol 0, diesel is 1, CNG means 2. This is required for machine learning models. And in 30th question is one hat encoding. Creates binary columns for each category. Example, fuel type petrol, fuel type diesel, fuel type CNG. Values are either 0 or 1. This prevents model from assuming original relationship. And then final conclusion is in this experiment, we performed exploratory data analysis, visualized data distribution and relationships, detected outliers and skewness, handled missing values, removed duplicates and irrelevant data, applied normalization and encoding techniques. These steps help prepare clean and structured data for machine learning models. And then that's all. Thank you.